Class 10 Trigonometric Identities R.D.Sharma Ch Chapter 11. It is question number 78, in which it is asked if x upon a cos theta plus y upon b sin theta is equal to 1 and x upon a sin theta minus y upon b cos theta is equal to 1, prove that x square by a square plus y square by b square is equal to 2. In this question, first we see these are some two terms. The value of this term is, each term is 1. So we can write this equation like x by a cos theta plus y upon b sin theta and plus x by a sin theta minus y upon b cos theta of whole square of both equal to 1 square plus 1 square. Now x square by a square cos square theta plus y square by b square sin square theta plus 2x by a cos theta into y upon b sin theta, and this will x square by a square sin square theta plus y square by b square cos square theta minus 2x by a sin theta into y by b cos theta. Here 1 square plus 1 square will make equal to 2. Here we see the term, this term will be deleted by this term. And now if we add x square by a square cos square theta plus x square by a square sin square theta plus y square by b square sin square theta and plus y square by b square cos square theta, which will equal to 2. And if we take comma here, s square by a square, we get here cos square theta plus sin square theta. And if we take common here y square by b square, we get here again sin square theta plus cos square theta, which will equal to 2. Now we know that cos square theta plus sin square theta will equal to 1. We can write here into 1 plus y square by b square will also equal to 1 into 1, which will equal to 2. Now we can write x square by a square plus y square by b square will equal to 2, and this will our value of right hand side. In question number 79, it is asked if x is equal to a cos cube theta and y is equal to b sin cube theta, prove that x by a in bracket raised to power 2 by 3 plus y upon b raised to power 2 by 3 is equal to 1. So we say here the value of x is this, so we can write x upon a is equal to cos cube theta, and y upon b we can write sin cube theta. So if you put the value of this in left hand side equation, like x upon b 2 by 3 and plus y upon b 2 by 3. We can write here cos 3 theta cube theta raised to power 2 by 3 and plus sin cube theta raised to power 2 by 3. 3 can divide this 3 and this 3 divides this 3. So we get here cos square theta and sin square theta. We know that the value of cos square theta plus sin square theta is equal to 1, which will the value of this is the value of right hand side. In this question 80, if a cos theta plus b sin theta is equal to n and a sin theta minus b cos theta is equal to n, then prove that a square plus b square is equal to m square plus n square. So in this question, if you take the term of right hand side, which is m square plus n square, according to this term, we can write m square as a cos theta plus b sin theta whole square, and n square we can write a sin theta minus b cos theta whole square. After calculating this, we get here a square cos square theta plus b square sin square theta plus 2ab sin theta into cos theta, and here we get a square sin square theta plus b square cos square theta and minus 2ab sin theta into cos theta. This term will be related by this term, so we get here a square cos square theta plus b square sin square theta plus a square sin square theta plus b square cos square theta. If we arrange this, we get here a square cos square theta and a square plus a square sin square theta, and write this term this side b square sin square theta plus b square cos square theta, and after taking comma as a square, we get here cos square theta plus sin square theta, and after taking comma as b square, we get here again cos square theta plus sin square theta. The value of cos square theta plus sin square theta is always be 1, so we get here a square plus b square. So we get here our left hand side term. In question number 81, if cos a plus cos square a is equal to 1, prove that sin square a plus sin raised to power 4a is equal to 1. In this question, we should to first write cos a is equal to 1 minus cos square a, which will equal to sin square a, and taking this equation, we can write sin square a plus sin raised to 4a is equal to 1. So we get here, we can write here sin square a plus, we can change sin raised to power 4 as sin square a whole power 2 is equal to 1. Now sin square a plus, we can write sin square a as cos a. We can write here cos a whole square is equal to 1. So here we get sin square a plus cos square a is equal to 1. So this we know that the value of sin square a plus cos square is equal to 1. So here is also 1. So left hand side is equal to right hand side. In question number 82, it is given if cos theta plus cos square theta is equal to 1, prove that sin raised to power 12 theta plus 3 sin raised to power 10 theta plus 3 sin raised to power 8 theta plus sin raised to power 6 theta plus 2 sin raised to power 4 theta plus 2 sin square theta minus 2 is equal to 1. If you see this term, so we can change this term like cos theta is equal to 1 minus cos square theta, and this will equal to sin square theta. And if you arrange this equation, we get here sin is 12 theta plus sin raised to power 6 theta plus 3 sin raised to power 10 theta plus 3 sin raised to power 8 theta plus 2 sin raised to power 4 theta plus 2 sin square theta minus 2. And if we see the term from here to here and compare it with a plus b whole cube, we see here the value of a plus b whole cube is equal to a cube plus b cube plus 3ab and a plus b. So we can conclude that these terms are matching to this. So we can write here and change this term according to this. We can write sin raised to power 12 theta as sin raised to power 4 theta cube, 4 here 12, and this term we can write sin square theta cube, and here 3 sin a 4 theta and b sin square theta, a again sin 4 theta plus sin square theta, and match check 4 2 is 8, 4 2 plus 2 6, 6 4 10. So we get here 3 sin 10 theta and 4 2 6 6 2 8, there 3 sin 8 theta. So our equation is complete, and right here 2 sin, and we can change this sin raised to power 4 theta as 2 sin square theta raised to power 2 and plus 2 sin square theta minus 2. So we can write this term from here to here as sin 4 theta plus sin square theta whole cube, and here we can write 2 sin square theta, 2 sin square theta, we can write here in place of sin square theta we can write here what cos theta, we can write here 2 cos square theta plus 2 sin square theta minus 2. And if we write as sin 4 theta plus sin square theta cube and take gamma as 2, we get here cos square theta plus sine square theta minus 2. We can further change sine 4 theta, rest of 4 theta as sine square theta whole square and plus sine square theta cube and plus 2 into the value of cos percent is to 1 minus 2, and the value of sin square theta we can take from here cos square theta and plus sin square theta whole cube plus 2 minus 2, 2 into 2 minus 2, and the value of cos theta plus sin square theta is equal to also 1, 1 cube plus 2 minus 2. We get here 1 plus 2 minus 2, which will equal to 1, and this is my right hand side term.